g of x is equal to this value here. Show that the equation g of x equals 0 can be written as this thing here. For x less than 6, the root of g of x equals 0 is alpha. The iterative formula here for x0 equals 2 is used to find an approximate value for alpha. Calculate the values of x1, x2, x3 to 4 decimal places, and by choosing a suitable interval, show that alpha equals 2.307, correct to 3 decimal places. Okay, I've got the question here then, so let's do part A. Okay, so what I'll do is I'll move this out of the way and we'll do part A along with the rest of the question. So I'm just going to move this down out of the way now. That's the rest of the question there. So let's just do the first part then. Okay, g of x equals 0, so here then e to the x minus 1 plus x minus 6 is equal to 0. Okay, so move this over the other side. E to the x minus 1 then is equal to, move the 6 over, move the x over, flip the sign of both, and then take logs to base e, so e swings down is the log of 6 minus x. So all we did was take logs to base e. Effectively the e swings down to become the base, and the x minus 1, the exponent, just drops down to ground level. And that then tells us that x is equal to ln of 6 minus x. Move the 1 over to plus 1. And we did that for the log, so 6 minus x must be greater than 0. In other words, x must be less than 6. That's part A. Now let's look at the rest of it now. So we'll move this up just slightly. And now, there we go. So the root of g of x is equals 0 is alpha. The iterative formula here is used to find alpha. Calculate x1, x2, x3 to 4 dp. So here, part B. Okay, x2 is equal to ln 6 minus x1. Oh, x1 we need first, don't we? So let's do x1 is equal to 6 log of 6 minus x0 plus 1. x0 is 2, so put that in. So x0 is 2 then, let's work that out then. So 2 equals, so we got that in the answer. So we'll do log of 6 minus the answer, close bracket, plus 1 equals 2.38629. 2.38629 x2 is equal to, so all we have to do is press equals again and it feeds it back in here as the answer. 2.284733. 284733. 2.28473. x3 then 284733, yeah, and then press equals once more. 2.312450. 2.312450. x4 is equal to, press equals once more, 2.304962. 304962. So to 4 dp we need to work these out, don't we? 4, so it's 2847. That's the 4 dp. This one, 3125. 4 dp, and this one 3049, 3050 to 4 dp. Okay, there's our numbers then. By choosing a suitable interval, show that alpha is 2.307 to 3 dp. So let's have a look at this then. So let's try okay, so g of x is equal to, let's just write down what g of x is first of all. It's e to the x minus 1 plus x minus 6. But we're doing this iterative formula, aren't we? We'll do the g of x, e to the x minus 1 plus x minus 6. We can look at this. Should show that alpha is equal to, so the root of this. Okay, so we could do that. We could look at that value, or we've got the iterative formula here used to find alpha, so we can use this iterative formula, can't we? And we've done that. Show that alpha is equal to that. Well, I'm just going to use the g of x formula here, the actual formula, and it was 2.307, wasn't it? So g of 2.3065, and I want to work out g of 2.3074 and see if it crosses, see if one is positive and one is negative. So let's work those out then. That's the way to do it, isn't it? So e to the x minus 1, so shift e to the x minus 1, so it's 2.3065 minus 1, that's what we got there, plus 2.3065 minus 6, which is minus 2.75 times 10 to the 4, minus 2.75 times 10 to the minus 4, which is less than 0. Now let's try the instead of 3065, 3074 there, and also in here, isn't it? Hopefully we get small positive. 3.95 times 10 to the minus 3. Which is greater than 0. So alpha lies in interval. Well, it would be 2.3065 up to 2.3074. So the root lies between. So to 2 dp, consequently, alpha is equal to 2.307, isn't it? 2 3 decimal places.